So the problem with naive adaptive histogram equalization is that if a particular block has some noise, then the regular AHE adaptive histogram equalization over amplifies this noise. So to solve this problem, we use what we call contrast limiting. And that gives rise to the contrast limited adaptive histogram equalization algorithm. So for regular histogram equalization, or even for adaptive histogram equalization, we compute the histograms in each of the n cross n bins separately, and then we compute the transformation function, we compute the cumulative distribution function, which gives us the transformation function for each of the bins. And we saw in the previous lecture that instead of readily transforming the pixels in the blocks individually, we use bilinear interpolation to finally assign the values of the pixels in the transformed image. So this is the only difference in the naive adaptive histogram equalization and the CLAHE operator. So we can just write these two side by side. Naive and CLAHE. So in naive method, we divide the image in bins. In CLAHE also we divide an image in n cross n bins. Then we compute the histograms P such histograms. Here also we compute P different histograms. In the naive adaptive histogram equalization, we then compute the transformation function, which is the CDF, cumulative distribution function, of each of the individual histograms. Whereas in the CLAHE, we first clip each of those histograms. So this is our additional step. We clip the histograms with a user-defined threshold. So there's a threshold tau, and we clip the histogram with this user-defined threshold. Then we obtain new clipped histograms, and then we compute the transformation functions Ti, CDF of the clipped histograms. So this is one additional step, and then as the last step, we apply bilinear interpolation. Here also, as the last step, we apply the bilinear interpolation. So this is the only step that separates CLAHE from the naive adaptive histogram equalization. So now we'll discuss what this clipping step is. So the rest of the code for the CLAHE operator would remain same as the naive adaptive histogram equalization, and the algorithms are almost identical. The algorithms are identical except for this additional clipping step that we have in the CLAHE operator. And now we'll discuss this clipping step.